Anand, thank you so much for joining me today.
Great to be here, Prateek. Thanks for having me on.
Let's start with the basics. LLMs are everywhere, large language models, they're being used everywhere, and there are some problems. So, what are some of the more common failure modes of large language models?
Yeah, absolutely. I'd say there's a lot, and I think what's interesting about especially the last year, is that uh, folks are using language models in all kinds of ways. I think in a lot of ways that some of us are working on the research side for the years before never could have expected, and so one way that a lot of companies have started to use language models is through retrieval systems, and so we're seeing a lot of different types of failure modes, like the classic one being hallucinations with the outputs themselves, but also architecturally speaking, issues with the context that's retrieved from the vector database, which then results in hallucinations and things like that. Uh, Other kinds of ways that we've seen a lot of companies use language models are for chat assistants. And so, in many cases, companies want to make sure that uh, ultimately there aren't any failure modes related to tone of voice, style, conciseness, bias, brand alignment, company policies, regulatory policies. And so, there's a lot of failure modes we've seen across those kinds of use cases. And then there's some other general dimensions that we've heard a lot about that folks are concerned about from failure modes. That includes copyright violations, as well as things like leaking business sensitive information and other kinds of privacy issues. And of course, other kinds of things like harmful content and more on the safety piece related to toxicity. And so we're seeing a wide range of scenarios that folks are using language models for, and the failure modes are also across those ranges.
Amazing. So many different topics to touch upon here. If you look at all the failure modes, some are easier to address than others. So, which failure mode or modes are the most challenging to address here?
Yeah, definitely. So I'd say one particular failure mode is a hallucination, and that's it can come in different forms. And so in some cases, the thing that people most reference is if a language model produces some kind of output that is just completely, in fact, completely inaccurate. And so this could be a numerical answer that's wrong. It could be just a fact that was made up that wasn't referenced in any kind of source data, and so we're seeing things like that happen, especially with hallucinations. But also, there's the other side of it where, for example, language model might answer, "Hey, I'm sorry, I can't answer that question." Where in the scenario where it actually did have the answer to the question, and so we're seeing both sides of it, where it refuses to answer when it should have answered something.
And when you build a large language model, you can build it from scratch, or maybe you can start with open source, you can fine tune it. Maybe you'll have some of your own documents and you can use RAG. But basically, you build a model, and before you ship it out, meaning before it goes to production, you got to test it. And testing at this point, at least where we are, it's a bit of a craft, meaning there's no like gold standard of 100% coverage, every possible edge case covered. So we're not quite there yet. So how do you think about automated evaluation of AI models? Like, where are we in that regard?
Yeah, absolutely. So I'd say that today most companies are still evaluating their language models and language model systems very manually. And so a lot of large companies have budgets for internal QA teams and external consultants that are manually creating test cases and manually grading outputs in spreadsheets. That was actually one of the very first reasons why we actually got started with Patronus, when we heard about that, which was, incredibly surprising. And then even the kinds of companies that don't have those kinds of budgets, some of the smaller companies or mid-stage companies, are spending a lot of expensive engineering time, that where they spend a lot of that time creating test cases by hand, trying to use approaches like, for example, LLM-based evaluation with GPT-4 or some other kind of model in order to evaluate their own GPT-4 to figure out other instances where models fail for their specific use cases. And so I'd say across the board, automated evaluation, it doesn't really exist. And the key reason for that is automated evaluation today and the kinds of techniques people have tried to implement just don't work. They're just incredibly unreliable today. And so typically when I talk to developers that are trying to develop their own automated evaluation system using something like GPT-4, they tell us that they have probably 5% confidence in automated evals. And so what they end up having to do is to, for example, write code to check every individual piece of their system, or they just have to manually review everything by hand. And then they do that in a very manual process where they change something, perhaps a particular token, and they get a different result. And some people talk about this whack-a-mole problem that everyone runs into.
Maybe it's a good stopping point to talk about the company you co founded. So you're the CEO of Patronus. For listeners who don't know, can you quickly explain what you do?
Absolutely. So at Patronus, we're very focused on helping companies be able to catch mistakes that language models make and language model systems make, and to do that in a much more reliable and scalable way. And so we have a very unique research first approach to how we do that, where we actually train and develop very high quality automated evaluators that you can use in one line of code in any part of your workflow, whether that's in pre-production, whether that's in post-production. But the goal of that is to actually get automated evaluation results that you can actually trust and that are actually reliable, and to solve that 5% confidence problem that I was just talking about a few seconds ago.
Now, coming to the topic of automated evaluation, can you quickly explain the mechanisms that are available to do that? And also, what is its impact on the development cycle of an average AI model?
Yeah, definitely. So I'd say there's a couple of different approaches that people have typically tried today. So one is they might use some kind of a metric off the shelf. So sometimes you might be looking at let's say Blue Score or Perplexity or some kind of training metric for NLP, and you try to use that in evaluation. Or there might be other kinds of metrics that folks have seen in open source, or maybe develop something of their own, where this might be something related to toxicity or PAI or something that is from an open source package in some way. Or there's ways for you to just customize that by yourself. Maybe, for example, you might be writing code to create an actual evaluation function, and maybe you're trying to test something very specific, and it's some kind of heuristic that you're trying to really determine in terms of the capability of a particular model or language model system. And then the other approach is to use another language model to evaluate your language model system. And so this could be GPT-4, it could be a Mistral, it could be anything that you trust to work really well as an evaluator. But you do that because you want to automate that in a much more intelligent way, and you want to be able to perhaps tackle more use cases in much more custom ways that can't be done through general metrics or even evaluator functions that you've written. And so those are a handful of the couple of approaches that we've seen people attempt to do. But the similarity across all those approaches is that they've all been shown to be pretty unreliable today in terms of how people approach it today, which is why today still companies are relying on manual evaluation as their main approach.
How do we strike a balance between LLM's creativity and it has its use cases? Many people use it to create images, create text. So LLM's creativity versus the risk of generating inaccurate content, right? And what role does like mistake detection play in this equilibrium?
Yeah. So I'd say that typically where we've seen mistake detection become really important is for companies that are using AI in mission critical scenarios. So this typically might be a company in some kind of a traditional or regulated industry. So, for example, let's say financial services, where the cost of an error that a language model system could make is really expensive. And so you always want to make sure that the margin of error is as low as it can be. Whereas for other kinds of products and other kinds of companies, that just might not be the case. And so if we think about a company that is a writing assistant, a company that's developing a writing assistant tool for writers or journalists, or for other kinds of creative professions, in those kinds of cases, a hallucination could actually be fun, or it could be engaging for the end user. And so we don't so far see a ton of attention from those kinds of folks given to evaluation. But even in those kinds of cases, you might want to just make sure that language model outputs are following a certain tone of voice, like a brand voice, for example, or it's following a certain style. And so it isn't necessarily about mistakes anymore, but it's just about the quality of the output of that.
Adversarial testing is crucial for uncovering hidden vulnerabilities. So Can you explain what it is and how it works in this situation?
Yeah, definitely. So the way that we think about evaluation data sets is in a few different categories. So adversarial is one of them, and then is another type around standardized data sets or benchmarks, and then there's another type around creating data sets that are, for example, similar in distribution because you're trying to identify patterns of failures. And so if we focus on the first one being adversarial data sets, typically this is a set of examples. It could be just a set of prompts, or it could be a combination of prompts and corresponding labels, perhaps ones that you've put together yourself. And the goal of this is to really identify as many vulnerabilities as possible. And so the results that you get from an adversarial evaluation should not ever be compared with a standardized evaluation, just because with adversarial evaluation, you might see a much lower performance result, but that's just because you're specifically trying to attack the model or attack the system and understand the exact kinds of gaps in terms of where it fails. And so I typically think of adversarial data sets as ones that actually contain lots of examples that are as out of distribution as possible for your use case and just broadly the language model itself, which today is actually really hard to create on your own, just because you usually have to come up with those kinds of examples yourself, or maybe in some ways inspired by what users are actually doing in production. But you can't necessarily generate those kinds of data sets synthetically, just because if you do, then it might just be from the distribution that the language model is actually trained on. And so I'd say that we typically look at adversarial data sets as examples that are out of distribution, edge cases, harder examples, and the kinds of ways that ultimately users might be playing around with your product at some point.
When you use adversarial data sets, right, what are the edge cases that we can hope to uncover? And also, like, what does that teach us about the behavior of AI models?
Yeah, definitely. So one funny example about this is we've talked to a lot of folks that are developing AI products and what their users actually end up doing. And funny enough, even if you put together a chat assistant for customer service or for developer docs that is completely external, there might be users that are not asking questions that are in any way related to what it was intended for. So sometimes there might be users that are asking questions about who the president of the United States is, or what was the what was the United States GDP in 2021. And so there's just all kinds of questions that are completely unrelated to customer support. And so in those kinds of cases, uh, you might just have a language model system that isn't prepared to answer those kinds of questions, and maybe shouldn't be answering those questions at all. So let's just say you fine tune a model that is specific to answering questions related to customer support on top of your documents, and now you've prompted the model to do something completely different. It might ultimately result in a failure, and even if it doesn't, it just might not match with what the brand or the product was supposed to do. And so in those kinds of cases, we try to make sure that you set up all the right kinds of guardrails so that you ultimately don't see any kinds of surprises in production.
When it comes to auto generation of an adversarial data set, what future advancements can we expect in this area?
Yeah, definitely. So I'd say that in general, I'd say that the challenging part about evaluation data sets today is that you have to create them manually, and typically, especially for very specific use cases, you might be spending hours just creating a few examples, because I'd say by nature humans are not creative sometimes, and so it typically takes a lot longer to actually create a really really high quality data set. And so we've seen a lot of people try to gravitate towards ways around generating data sets automatically. But the challenge with that is, a few fold. One is, how do you actually know whether this data set actually covers the full scope of the use case that you and, let's say, the business unit that you're working in actually wants to cover. But also, how do you know that, for example, the actual test cases are diverse in distribution? And then the third piece of this is also, how do you know that the data set that you've put together is in many ways mimicking what might actually happen in production with users? And so the way that I see the long term of auto generation of adversarial data sets is uh, being able to factor in all those kinds of inputs in a way that ultimately gets you the kind of data set that meets all the different types of criteria, and being able to measure those specific criteria in very specific ways is what you should be doing as you're going through the iterative process of actually developing that initial adversarial data set.
When you think about copyright detection, it has become a hot topic, and especially as large language models that use like huge data sets without really looking at copyright law. And so as LLMs become increasingly capable of generating human like text, right, the copyright issue becomes a big problem. So how are the current models equipped to handle this challenge? And also, what work is being done to address this?
Yeah, definitely. I'd say what's surprising is that all models across the board, all the state of the art models, do elicit and ultimately produce copyrighted content verbatim. And so this was actually something that we announced roughly a month ago, where we actually developed Copyright Catcher, which was the first copyright detection API for language models. And as a part of that work, we actually also published research results around how state-of-the-art language models actually performed on adversarial data set that we put together. And it was really surprising to see the failure rate across the board. And so, what's challenging about this is that typically, the larger the model, the more performant it is, as we all know. And typically, the models that are larger uh, tend to do better because they were actually trained on copyrighted content. And so, in many ways, you have that trade off where, in order for you to get a really, really powerful model, you do have to train on copyrighted content. But on the flip side, if you were to do the reverse, where you try to only focus on, let's say, public domain related data, then you end up typically with a smaller language model, which is also not as performant. And so, the way that we approached this problem was not to encourage companies to develop smaller language models, but rather still develop very high quality language models, but ultimately be able to use a security mechanism like the copyright catcher from Patronus to be ultimately able to catch these types of mistakes before they ultimately go to the end user. And so we heard a lot about how at large enterprises there are marketing teams and sales teams that are now beginning to use AI products where they're generating copy that they can use in the work that they're doing. And they're concerned about using accidentally copyrighted content. And so the goal of Copyright Catcher is to be able to catch these types of copyright violations after the language model has returned an output in order for you to then intercept it and then prevent it from ultimately being used by any of the end users.
So if company A builds the foundation model and company B uses that model to build a product and that gets shipped out, and that product now accidentally generates copyrighted material, right? So in this case, are they both at fault, or does one of the companies like share more of the blame than the other? How does it work here? And if that
Yeah.
happens?
Yeah, I'd say that the answer to that question is still unresolved at a legal level, especially with, for example, what's happening with the New York Times and OpenAI lawsuit, where to companies today, the risk or the liability in terms of who owns the liability is actually still unclear. And so, what we also expect is that even if that liability falls on company A, who develops the foundation model, company B would still be concerned just because they're ultimately using that foundation model, and it could still be, in some ways, they might be potentially held responsible for things that they might not expect over time. And so, in many cases, regardless of what happens with the legal environment around this particular topic, we're just hearing a lot of enterprises be concerned about using language models in the first place, just because they know that there's risks involved, both at a legal level, but also even from a reputation or brand level in the long term.
Retrieval augmented generation has been a fascinating development in AI, and also in many cases, um, it just comes in very handy when a company wants to use it for an internal tool, or if you want to verticalize a foundation model for a specific subdomain. So, just to get started, can you explain how it works and why is it important in the LLM world?
Yeah, so I'd say that retrieval augmented generation is really important because it ultimately empowers a team or a company to actually leverage internal data in context with how they're using the language model for their particular application, whether it's an internal use case or an external use case. And so at the highest level, it ultimately prevents hallucinations technically because it's ultimately referencing some underlying source data or context that it should be referencing. And so now all of a sudden you have a language model that is very capable of being very personalized to that particular company and whatever its use case is going to be. And so typically what developers do in order to get that set up initially is they have some kind of a data store and they ultimately uh, uh, essentially save those kinds of documents into a vector database of some kind in the form of embeddings. And they use that in order to consolidate a lot of the information and the knowledge that's across this data store. And then they pair that with a language model in order to then ultimately make sure that when, let's say, some end user uh, prompts the model, they're ultimately able to get an output that is very relevant to what was in that data store. And so vector databases become really useful, especially when you're dealing with, let's say, thousands or tens of thousands of documents, where you want to be able to represent that information in a much, much more succinct way and concise way. And so that's where it becomes much more useful.
Let's consider two scenarios. Scenario A is just a normal AI model, the foundation model, you just pick it up. And scenario B is an AI model plus RAG, right? You just take internal data and you build a model to do that. So, in terms of testing or evaluating these two models, what's the difference when it comes to the evaluation process? Do you have to do something extra for the RAG model, or is it all the same?
Yeah, absolutely. So I'd say it is pretty different when you are trying to evaluate a retrieval system as opposed to a language model in isolation. And the key difference is that architecturally it looks really different. Where language model isolation is simple to get started with. You can just query the API, you can see the output, you can inspect, relative to the prompt and perhaps any context you include in that prompt, what the output looks like. And so whether it's manual evaluation or automated evaluation, all you have to do is really just look at the prompt to the language model and the output that came from it. But the key difference between a language model in isolation and a retrieval system is that with the retrieval system, you also have to look at the retrieved context from the vector database. And so the context is really, really important because that's what's ultimately informing the language model in terms of how it should actually answer the original question. And so what's important is not even just what's in the context, but even the size of the context. And so people typically look at the chunking strategy or the chunking approach that they use in order to figure out how large should the context be when it's being retrieved to answer this particular question. And the size of that, for example, can definitely impact the final output. And so, in terms of how you evaluate the a retrieval system, you would want to look at things like context relevance or context efficiency in order to really measure the quality of that context. And then once that context is good, the next thing you want to measure is the quality of the output relative to that context. And so that would be where you would measure whether or not a particular output was a hallucination, or, for example, how relevant was the output itself relative to the original question. And the interesting thing about evaluating retrieval systems is that you can't just evaluate the context in isolation or even just the output in isolation. You have to not only do that, but also do it as an end-to-end pipeline. And this is because sometimes you could actually have really good context, but you could actually end up with bad outputs or inaccurate outputs, and that could just be because perhaps the chunking strategy was not correct, and you need to do some final iterations. But typically, we've seen folks be able to experiment with different parts of the retrieval system architecture to get to a really good final outcome with their AI product. So this could be not just the trunking strategy, but also the retrieval algorithm or the indexer type, or even the base prompt that was used to construct the model, or what the embedding model was, or whether or not you've fine-tuned the embedding model, and a number of other kinds of parameters as well that you can use to get to that final happy state.
Fine tuning has been, at least so far, people have been using it, and RAG obviously has a role to play here. But as you look at LLMs becoming better and better over time, where do you see fine tuning ending up? Like, will we use it less and less as LLMs get better? And also, fine tuning and RAG, what's the relative role they'll play in the future?
Yeah, definitely. So I'd say that I actually would expect fine tuning to become even more important over time. And the main reason for this is even if language models continue to get better, they're only getting better on publicly available data. And there's a really, really, really large amount of data that is privately owned inside of companies and individuals and locally. And so we expect that to play a much bigger role. I'd say another part of that is there's just only so much you can actually accomplish with prompting on its own, and there is sort of that, let's say, carrying capacity or upper bound in terms of the performance you can get with prompting. I'd say even today, even that hasn't been fully recognized, where there is a lot more that people could do with prompting to get to even better performance. But if you want to go beyond that upper bound, fine tuning makes that possible, because now you can actually guide the model to an even better performance and ultimately the best direction with domain specific data. And so we definitely expect fine tuning to become even more important.
If we look at the process of prompting, it's basically your it's a discrete sampling of the space, meaning you hope to construct prompts, and you want to discover, hey, does the LLM fail here? So will prompting still remain the primary modality, or will there be a continuous function equivalent where, hey, mathematically we guarantee the performance because it's been tested, and not like manually constructed prompt, which is basically sampling of the space?
Absolutely. Yeah. So I'd say that over time, we definitely expect it to be the latter, where there will be a continuous function, like you said, in terms of how companies will optimize prompts to get to the best performance. But I'd say that for today, there are a number of use cases where you can get most of the value even without having to do that. And so for some of the simpler use cases, that's totally plausible. But as we continue to leverage generative AI and much, much more complex use cases, I definitely expect that to become the way that people interact with prompting. And exactly like you said, because it is based on sampling space, the way that you construct that prompt really, really makes a big difference. And in many cases, we've worked with a lot of developers, and even in our internal research, we found a lot of cases where even changing a single token in a prompt could result in a very different output. And the other thing I'd mention as a part of this is that, especially today, the way that you prompt one model won't give you the same results for a different model if you were prompted the same way. And so, especially as companies are starting to use multiple language models inside of their larger ecosystem of models that they're using to develop their product and to power their product, we definitely expect very specific approaches to every individual language model that they expect to use over
I
time.
have one final question before we go to the rapid fire round. What technological breakthroughs in AI are you most excited about? And again, maybe not just limited to what's relevant to you, but in general, what breakthroughs excite you the most?
Yeah, I'd say there's a lot of things. I could even rapid fire this one too. So I'd say that in general, I'm very, very excited about a number of different things like multimodal models, and also, of course, what OpenAI did with Sora recently is just incredible to see. I'd also say that from an architectural standpoint, really excited about state-space models and what that could mean for how people develop new AI products over time, especially given the limitations of transformers, for example. And I'm also actually really excited about the future of evaluation, not just for language and text, but all kinds of different modalities. And so I have friends that work at robotics companies like Covariant that tell me every week that they wish they had a product like Patronus for evaluation. And so we're continuing to see a lot of companies struggle with this problem in different types of domains and verticals. And so we expect there to be a lot more really interesting and new research coming out around new evaluation alignment techniques that ultimately will get people to much better performance and much, much better products over time.
All right, with that, we're at the rapid fire round. I'll ask a series of questions and would love to hear your answers in 15 seconds or less. You ready?
Yeah.
All right, question number one. What's your favorite book?
Yeah. My favorite book series is actually Harry Potter. It was actually the first major set of books that I actually read when I was a lot younger. And I love it. I've read every book several times over, watched every movie, and so it's my favorite book.
Yeah, amazing. Same here. I read them during my formative years, and for some reason, Goblet of Fire has been like one of my favorite reads. I've read that book more than others. I don't know why. I just like it. All right, next question. What has been an important but overlooked AI trend in the last 12 months?
Yeah, absolutely. So I'd actually say my answer might be a bit surprising, but actually say I would say that fine tuning models has actually been quite an overlooked trend in a lot of ways. I'd say that in many ways, long complex models are amazing, and I'd say everyone's gotten really excited about them. But I actually expect that over time, domain specific fine tuning on domain specific data will definitely yield a lot more value over time. And I think I'd say the reason why it's been overlooked is that there are a few more hurdles to make that possible, whether it's ML infrastructure or the right kind of service to use or the right kind of budget and even people on the team to make that kind of work possible. And also, of course, today it's really hard to uh, quantify the ROI of fine tuning if you don't have really high quality evaluation. And that's where, of course, Patronus plays a role into.
What's the one thing about evaluating AI models that most people don't get?
Yeah, I'd say that the thing that most people don't understand is that not all evaluation is treated the same, and every approach that we've seen people take to do evaluation just doesn't work well. And so, for example, we've seen a number of folks try to use metrics off the shelf or from open source, like Blue Score or Perplexity, to be able to measure language model performance for a specific use case. But most of the time, it just doesn't work that well. And actually, my co-founder Rebecca wrote a research paper about this in 2022 at Meta AI, where she actually focused on, for example, Blue Score and how it doesn't actually correlate highly with human judgments. And so there's a lot of things that I'd say people don't understand today about how to do evaluation, which we expect to get better over time. And then similarly, I'd say that manual evaluation on its own also has a lot of biases because even humans that are grading outputs might have internal biases of their own, and so there's no, there's no golden bullet for it.
What separates great AI products from the merely good ones?
Well, I'd say that this is very highly reliable evaluation. So the companies that we've seen that have been able to have really good uh, automated evaluation have been able to get to really good performance over time, and then in those kinds of cases, they ultimately have really happy users, really successful products, and they also don't have negative attention in the press because of something that chatbot did where it went off the rails, or perhaps a language model that was released that didn't go as well as it expected.
What have you changed your mind on recently?
Yeah, so I'd say that from our perspective, in terms of how we focus on uh, the messaging of our company and how we talk about the company in general, I'd say that what's interesting about evaluation is that it's no longer just a single term that means one thing. I think the definition of evaluation has diverged in many ways, and the way that we approach evaluation is much more from a security perspective, and this is because we focus on actually helping companies catch real failures with language model systems, as opposed to just providing you some tooling that can automate one piece of the workflow. And so we actually see evaluation as a very important part of AI security. And it's something that I wouldn't say that we necessarily thought of when we first got started a year ago.
What's your wildest AI prediction for the next 12 months?
Yeah, well, I'd say that my wildest prediction would be that small language models are going to continue to become very powerful over time. And I would say that this is the case not just for language models that you can use for your AI products, but evaluation models as well. And so I'd say that we're going to continue to expect uh, models that are cheaper, faster, but also still highly performant, and can work anywhere under any kind of infrastructure, even locally as well.
All right, final question. What's your number one advice to founders starting out today?
I'd say the number one advice if you're starting out today is to pick the best co-founder that you can, and I'd say that especially because my co-founder Rebecca is incredible and is a really big reason for why we're here, and so I'd say that the first most important decision that you can make as a company is to pick the right co-founder for you, and so that's where I'd start.
Amazing. Anand, this has been a fantastic discussion. I think we're at a phase where AI models, the experimental phase is coming to an end, and we want to put them to use in like real products in the real world. So I think evaluating and testing them properly, I think it plays a big role. So yeah, I loved hearing your insights. Thank you so much for coming onto the show.
Yeah, thanks so much, Pratik. These are all awesome questions, and really enjoyed being on here with you today.
All right.